Like, oh, aku boleh copy paste lagi. Mati sendiri. Musik atau
Mana?
I hate the imperial system.
Okay. You want to give a shot? What's your material? Which one are you doing?
400 kilo steel pallets.
Steel pellets, okay? So what do you recommend? That's a very heavy load.
I recommend chain-driven roller conveyor
Okay?
because it's best for 500 kilo steel pallets.
Chain-driven roller conveyor. Like this?
Yeah.
Okay? Keep explaining. Why do you pick this? Oh, come on. You guys already use GPT. Masa nggak bisa?
Because it can pull up to 1,200 kilogram per pallet.
Okay. Have you pull out the actual industrial catalog? What brand do you choose?
I choose Inroll pallets conveyor modules.
Can you spell it?
INTERROL. Then pallet conveyor modules.
This one?
No, the other one, the second one. Not that much.
Oh, this one. Okay. All right.
Yeah.
So which capacity did you pick? You said this one? 1.5 ton?
Around that.
Okay. So, what kind of motor do you calculate you need? Everybody listen to this conversation, okay? This is part of the class. So what's the motor that you calculate it to be?
The motor is around 100 or 2,440 RPM.
Okay. How much horsepower or watt? The size is not just the RPM, right? The size, remember the size of a motor is the power rating, not the torque or RPM. Do you know why? You remember from machine design? Why do we rate a motor based on watt, not torque or RPM? Because, come on, you can do this. What? Yeah. Why do we use horsepower or watts? Why do we use a power unit to size something? Not the torque. Because? Because RPM and torque are? Come on, what is the function of belt, drive, chain drive, and gears? What's the purpose of those? Transfer, but you can also do manipulation, ratios, right? So if I choose a motor based on the RPM only, RPM can always be reduced or increased. But you lose the torque, right? You increase RPM, you lose the torque, and vice versa. So torque and RPM is always, right, and they can be manipulated however you need it. But if you want both, you need horsepower or watts or
I
kilowatts.
was confused as like I thought you were saying why would you use horsepower over watts, and I'm like there's
W-A-T-T.
Okay, watt, yeah.
W-A-T-T. Okay? So power units, not torque units or RPM. So, how big of a motor?
Berapa HP?
1.5 horsepower. And what are the factors involved in your motor sizing? Yeah. What kind of, like, how do you come up with 1.5 horsepower? It is influenced by
Like the power. It's the same thing.
yes. How do you come up with 1.5 horsepower? You don't just come up with just make a guess right now, right? There's a calculation. That's the task.
Indo coba kau. Kekuatan cowoknya.
Okay, you need to explain that in your assignment, right? Okay, you wanna give it a shot?
Okay.
What's your assignment?
Cement powder.
Okay, cement powder.
Okay, so based on my conversations with ChatGPT, the recommended type of conveyor is the one that I chose is a screw conveyor.
Screw conveyor.
Yes.
Okay, what brand?
For this one, I used from WAM Group. WAM ES type. ES, yes.
Okay,
Scroll down a bit, sir.
like this.
Yeah, like that.
All right. Ash screw conveyor.
Yes.
Okay, talk more about it. Why do you pick this one?
So
And what are the issues?
So cement powder is it's
Can
powder.
you speak louder so everyone can hear?
So cement powder is it's powder, right? It's abrasive, right?
Yeah,
And
it's
if it
also
gets-
abrasive.
Yes, if it gets into and also the powder it can be bad for health because like asbestos, right?
Right.
So the advantage of using this is firstly, as you can see, the design is like a big tube, right? So it's dust.
It's enclosed.
Yeah, it's enclosed.
Yes.
So it's gonna prevent the dust from entering our breathing or also contaminating other stuff.
Okay.
And also, I mean, the design itself is good for transporting powders like that.
Okay.
Because, how do you say it? Okay. It's powder. If you use that, it's like it spins, but then again, it gets pushed, right?
Sure, sure.
Yeah, like that.
Okay, so you already highlight that for some hazardous materials, you need to enclose it, right? You don't want it flying everywhere. So that's a unique selection of conveying method, transport method. Okay. What about power calculation?
Power calculation. Can I just read the one side that I have?
Sure.
Okay, so for power calculation, we first need to assume that, let's say, so first we need to have some values. So firstly we have the bulk density of cement itself.
Okay.
I googled it. It's approximately 1,500 kilograms per meter cube. Now we also have the capacity of how much the conveyor will bring in an hour, which
Okay.
is also approximately 90.7. And also for the conveyor, there's also going to be the length and diameter. So the ones I have here is assumed to be 15 meters in length and 305 millimeters in diameter. So that's 30 centimeters. And the conveyor speed is to be 60 RPM
Okay.
with drive efficiency of 85%.
Okay.
So for calculation, we need to think about the material itself and also the friction. Because, as I said, it's abrasive, right? So with the formulas all over that, the final value that I get is about 0.1 kilowatts.
Okay. Are you assuming horizontal transport, vertical at an angle?
This is horizontal.
Horizontal.
All angles.
If it's an incline, then you're gonna you're gonna have gravity going
Yeah,
against
there's
you
going to
too.
be more
Right.
gravity and also
Yeah.
the mass itself.
So, guys, I'm not into memorizing formulas, but as engineers, my principle is that you need to understand when you calculate something, what are the influencing factors, right? So in this case, a screw design like this, obviously the tube diameter matters, right? Friction that you need to overcome, the mass rate, like how many kilograms per minute that you want to deliver, things like that. Okay, so that's why I tell you I want to know, let's say you come up with 1.5 kilowatt, like how, or 1.5 horsepower, how, right? What are the factors? You know, you don't need to memorize F equals M times A, but I know that my force is influenced by mass and acceleration. Okay? Yeah. So, all right, let's give another shot. You wanna share yours? What do you do?
So mine is for smartphones.
Smartphones, okay?
So depending on whether it's human intensive or automation, you can either use the pallet conveyor for automation or flat belt generally.
What belt?
Flat belt.
Flat belt, okay? What are the considerations?
So pallet is usually you have to custom make a tray.
Custom what?
Oh, sorry. So for the pallet is custom made trays, but for flat belt, because they're flat, smooth, they can transfer items without much interference. That also includes robotic arms or human interaction, so they can easily put in or take items.
It's
out.
flexible, right? It's flexible, it's simple. Yeah.
And it's easily spotted if there's damage or there's debris or dust, so it can be cleaned.
Okay. What you have to be careful though, depending on the process we're doing on the smartphone, like let's say you're just assembling something, then you just put it on and it just close, right? But if you have a machine working on it, then you need a jig. Yeah, you need a pallet, a jig, so it sits on a like a plastic piece, and then something works on it. Okay. But if it's just human, then yeah, just lay it flat here. One thing you have to do, you have to consider in electronics is static, electrostatic. So there are rubber materials that are infused with carbon, so it's ESD safe. ESD safe. ESD stands for electrostatic discharge. Okay. So there are rubber materials with carbon in it, so it discharges any static electricity because it's going to damage your MOSFETs and extra. Okay. Design calculation.
Design calculation, we consider the effective force, so it's usually considering what's it? The friction force and the gravity force. But usually the flat line doesn't go in an angle, so we consider it as 0 degrees. Or,
Okay.
yeah, not considered. Then we calculate the required power, and also assuming the starting factor for the start acceleration. Assuming the belt speed is around 0.3 meter per second, which is already considerably fast.
Okay.
The weight of a smartphone is like around 0.2 grams.
Yeah, it's tiny.
Yeah, tiny.
So in your situation, the friction, the belt friction coming on and off the roller is probably bigger friction than the smartphone mass itself. It's nothing, right? So your motor will be overcoming friction, rubber friction, more than the smartphone, right?
Based on calculation, it's around 1 watt, but considering the safety factor, at least 5 for this situation, it will be around watts or 0.007 horsepower.
Yeah, that sounds tiny to me. There might be some assumptions you have to redo, like the size of your conveyor. Yeah. Okay. All right. You wanna share yours? What material you're doing?
Coal.
Coal. Okay.
Coal, batu bara.
Coal. So the conveyor type that was chosen was through belt conveyor. Through.
Oh, trough.
Yeah, through.
Okay.
And there's a higher color.
What brand?
The Eco.
VI
FEECO.
FEECO.
Eco International.
Like that?
Yeah.
Something like this?
Like the picture on the left.
This one?
The bottom one.
Okay.
Like that.
All right.
It does have a lip on it. And from there, it says that
Can you speak louder?
the recommended belt is from standard Dunlop also from ChatGPT. Yes.
Okay.
The conveyor reference comes from Eco also. The belt width is from 18 inches to 72.
Okay. So why do you choose this one instead of the screw conveyor, for example?
In my opinion, so it's
Yeah, in your research.
It's way safer. So, what did you say the other one was?
His cement powder is using screw conveyor, like enclosed screw conveyor.
Oh, because usually when you transport coal, it's directly from the dig site, right? There's no. If you go into an enclosed space, it's gonna be leaking everywhere because machines going through and all that. So
Okay.
we mostly just put it in an open conveyor and drive it down.
and think about how coals are. I mean, some of them are chunks, right? Like
Yeah.
stone-like, and it's random in size. Like his cement powder is like ash. It's just a consistent powder, but your coal might be in like chunks, and it's gonna it's gonna be stuck in that screw. Okay, yeah. So this makes a lot of sense for like stones, rocks, sand. Okay, irregular sand. Okay, what's your design calculation like?
So, assumptions, the density of the bolt, 800 kilograms per meter cubic.
Okay.
Uh, Assumption for the transfer rate is 500 tons per hour,
Okay.
which if you check the capacity, it's like 130 to 140 kilograms per second.
Okay.
Uh,
What size motor are we talking about?
Your motor, I haven't chosen a motor, but I have done the calculation.
Mhm.
I have a mass flow of 140-ish, and we find the power for relay. It comes out to the lift is times gravity times the h, which is 5. Yes, the design is
Is it flat or inclined?
there's
Your
a
assumption.
100 meters total horizontal with at the end 5 meters net vertical lift.
Okay.
So from there we get power for it to lift the materials like 6.8 kilowatts.
Okay.
Uh,
That's the motor.
yeah, the motor.
Okay. All right. Good. Let's do something with the spatial items. Those of you in the back, right? You wanna? Right. Yours is high speed.
Yes. So I actually found. Is that okay if I probably do it right?
Sure.
Pada saat conveyor stop di bagian di belah conveyor tapi mulai dipanggilnya eskavator.
Eskalator.
Eskalator.
So I actually managed to found a.
Iya ya, kalau dikit-dikit eskavator tuh kayak conveyor manusia ya. Itu conveyor manusia.
Okay.
Iya, bener-bener. Kalau lift
Catalog for
conveyor vertikal.
Okay.
and it has all of the calculations. So there's like the
Area.
Okay. This is for an ice cube.
yes.
Ice cube.
So this is the horsepower calculation and lumps, and then we can also see the type of bearings.
So why do you choose first the type? Why do you choose a
Screw type.
screw type for an ice cube?
Because it's a lot simpler. It's just like a motor, and then you just have the screw thing, and that's it. You don't have to do a lot of maintenance. Like it doesn't. There's no rubber belt to replace. You don't have to tighten the belt, or
Okay.
like just there's less complexity. It's just the maintenance is basically just like the bearings.
So what's unique about transporting ice cube?
It's a bit wet, right?
Yeah, it's gonna melt.
Yeah.
So you gotta maintain some temperature isolation here, heat isolation.
And you can enclose it right with the screw types. And it's also a lot easier to clean. Like imagine trying to clean the belt with this thing, you can just like pressure wash it and just scrub it clean. And then if you, for example, don't want the ice to melt, you can also like add cooling, right? It's very easy because everything is made out of stainless steel.
Okay. What's your power calculation like?
So there's a lot of factors here. I've screenshotted all the tables.
Okay.
But basically, this is how many ice cubes, let's say 100,000 pounds of ice cubes per hour, and then like so we can actually see from here the capacity cubic feet per hour, right?
Mhm.
So at 100,000 pounds of ice cubes per hour. That calculates, using the table here, this is the density, which calculates about 2,857 cubic feet per hour.
Okay.
And then, this is not the number, 2,500 we want. You cannot see it. But yeah, 2,500 is not enough. So, go on to the next.
What column is this?
So this is the maximum capacity of the
RPM. Or
yeah, at maximum RPM. This is at
the
one-
capacity at maximum RPM.
Yes. So the maximum RPM here is
Cubic feet per hour.
Yes. So we have this is the density. You can see it from the table. Ice cube is about 333. So we're going with 335 this here. It's non-abrasive, 30% pitch. And then we want 18 inches because we want 2,800 something per hour, right?
Okay.
So we went with the larger one, and then this gives us 75 RPM and an 18-inch screw size.
Okay.
And then from that, you can see the. All right, and then from the table here it says 1B component group, and then from there we can see that it's normal surface, meaning. Yeah, I colored everything manually. I didn't use AI at all. So yeah, just wood bearings, ball bearings, or pivot bearing hangers, and these are the only maintenance items here because the screws are the unless you're. I mean, it's just ice cubes, right?
Well, it's heavy.
Yeah,
It's heavy, but it's not abrasive.
Yeah, it's not abrasive. Wood bearings, and then so since we're using wood bearings, we go back to the. What table was it? Alright, this one, 18-inch, and then since we're using wood bearings, it's 240.
240.
The factor for
Safety factor, or what factor is that?
honestly, I'm not sure. It just says D. See the factor table, and then we'll calculate this.
Okay.
I think what you can see.
So it just goes into the calculation.
Yes, that's the
It's variable D.
factor. Yes.
Okay.
D times S equals Q times Q. I'm not sure what factors, but it just says variable factor. And the RPM is 75, right? Because we Q, and then the F is 0.4, which is from here. That's 0.4. And then yeah, you just put it in, plug it in, and then it spits out like 2.9 horsepower. And then you have to count it by 1.25 because it says here. B is 1.4 inch, 2.4. And then there's safety factor, you have to divide it by 0.90, and then you
What
get
safety factor you use?
yes, 4 horsepower.
Okay. All right. Very good. Very comprehensive. Thank you. All right.
I'm glad I managed to find that the PDF for this.
Yeah, now I understand what you meant about the imperial units. That's
So why is there no humans?
what?
No humans,
No humans in what?
right? For the research,
What do you mean, no human?
right? Technically, escalator is also a conveyor for humans.
Right.
Awful.
In fact, I just saw a YouTube video on the history of escalators. Okay, so submit what you've done into the Google Classroom, okay? So now let's talk about some feeding systems. Now, these are not conveyor belts, but really, when we say feeding, meaning like a machine might be assembling like bolts or assembling part A to part B, put it together, okay? And these comes in bulk, and they wait in line to get into the machine. So these are called feeders. So let's look at some of them.
Feeder university.
Feed U presents Vibratory Feeder Basics. Vibratory feeders are a type of automation equipment that use controlled vibration to orient bulk, randomly oriented parts and provide a consistent feed of correctly oriented parts to a larger process.
these actually go upward. It's going vertical. Okay, it's not spiraling down. It's actually spiraling up.
Vibratory feeders are found most commonly in product assembly applications, although they are used in packaging, inspection, and other settings as well. Common industries that use vibratory feeders include the automotive, cosmetic, pharmaceutical, electrical, food and beverage, consumer goods, appliance, and manufacturing industries, although their applications are virtually endless. In general, vibratory feeders contribute to improved line efficiency, decreased downtime, operator safety, decreased part wear, final product consistency, and much more.
Now, here is what's pretty creative about the vibratory bowl feeders. Notice that there are two lines here, and it separates the one that is oriented wrong. Okay? And it takes some creativity to do that. For example, you have a part like this. Okay? Like a cup. This is the cross section. Okay? Now, if you want the part to come to your machine this way instead of this way, in the vibration feeder, you can have a rail that is shaped like that. And then, if your part is this way, then it's going to fall out. Do you see that? But if your part is this way, then it's going to sit there. And it's not going to fall out and start over from the bottom. So these kind of mechanisms make sure your part go into your assembly machines in the right orientation. So it takes a lot of creativity to do this.
In process automation, consistency is key, and vibratory feeders provide a consistent and constant feed of parts.
So that thing, so this, I mean, it fell out, but usually this will go into your assembly machines. Ngerti ya? So these are your supplying components.
It's key, and vibratory feeders provide a consistent and constant feed of parts in the same or similar orientation, so each segment of the process can work predictably, minimizing downtime and operator error. They specialize in applications that call for 1 to 250 consistently oriented parts per minute and improve overall efficiency while removing personnel from potentially hazardous steps.
And it goes by vibration, by the way. So there is no air pushing it or belt, right? The vibration moves things forward.
The most common style, straight wall, is the most versatile, although they can take on the walk and cascade styles to suit specific needs. All vibratory feeders feature two distinct components that make them function: the drive unit and the bowl. The drive unit mounts to the bottom of the bowl, and you
Notice the angle of this plate, and this is a magnet. So by actuating the magnet in an oscillatory way, you actually vibrate it this way. And because it's at an angle, when you pull on this plate, it actually actuates your part forward a bit. Okay, so an example of a light part, something like. Okay, so if this is the plate, or this is the whatever bowl it is, it makes it jump this way forward. So it kind of, you don't see it, but the vibration makes it crawl, and that's what enables it to go up even, because the vibration is actually shooting the part at an angle.
uses electromagnetic coils to produce the vibration, typically between 60 and 120 hertz. The coils, in combination with angled spring banks, cause the bowl to throw the parts up and forward as it vibrates, creating a low friction movement that characterizes vibratory feeders. The bowl, typically constructed from stainless steel, is the component that contacts the parts and is outfitted with custom tooling concepts that physically manipulate the parts as they travel around. Feeder bowls are typically custom fabricated to suit each application and can be very simple or incredibly complex depending on the physical nature of the parts and requirements of the automated process. In addition to metal tooling features, some feeders require directed, pressurized air to properly manipulate the parts. And to satisfy even the most difficult or delicate part conditions, feeder bowls can be coated or covered in a variety of materials to reduce noise levels, excess wear, or provide extra grip or traction for the parts they are feeding.
Sometimes you have air throwing out the wrong orientation.
Coatings and linings include plastic compounds, bristled matting, rubber matting, metal plating, and more. Vibratory feeders impact the production of many of the products we interact with daily. And with so many custom variations, it can sometimes be difficult to interpret what kind of feeder is best for each application, or why a certain feeder was selected. Visit HoosierFeederCompany.com for your parts feeding need.
Okay. Now that one was vibratory feeder, but
Welcome to Homer City Automation, manufacturer of Syntron rotary feeders.
this one is rotary.
Rotary orienting feeders, also called RO.
The difference between vibration and rotary feeder is that this rotary feeder physically have a spinning bowl, okay, and it has a spinning base. The other one, it doesn't spin, it vibrates, and it makes the parts jump. This one actually rotates.
X offer manufacturers an efficient solution for feeding parts in a manufacturing process. Feed and orient parts. Rotary orienting feeders are noted for their ability to feed and orient parts at high rates that cannot be matched by other types of parts feeders. In addition, the feeder performs at very low noise levels, therefore improving the work environment for the operator. Syntron's rotary feeders are widely used in food handling applications. Just a few examples are frozen hash.
So these bowls, I mean, a human will come with a bin and they just throw everything in, right? And then the feeder bowl kind of do the job of feeding the machine one by one.
Browns, pickles, and potatoes, as well as wrapped camp.
So
A few examples are frozen hash browns,
what do you think these are for? What are these plates doing? Aligning?
Riding up, jumping off.
Aligning or
Pushing it
make
down.
the wrong orientation fall and start over from the bottom again. And so you will end up with the correctly oriented ones.
QC.
pickles, and potatoes, as well as wrapped
See that?
candy.
Oh yeah.
We offer these units in 18, 23, 32, 42, and 57-inch diameters in either standard or custom designs. Standard rotary orienting feeders come equipped with an adjustable stainless steel fence, and you can add your own orienting devices to meet your specific requirements. As the video shows, many different kinds of parts can be handled by the rotary orienting feeder. Lightweight parts such as plastic caps, spouts, capsules, and electrical connectors are handled with ease. The rotary orienting feeder is equally compatible for handling heavy parts such as anchor bolts, bearings, and metal sockets, and easily handles oily parts.
Okay, do you see the air throwing it out? This is an airline. Okay, it blows air. So if something is horizontal instead of vertical, they got thrown out by the air. See?
If a custom feeder is required, Homer City.
So if it's upright like this, it doesn't get blown out. But if it's this way, it gets blown out. Pretty creative. I think it's pretty cool. I mean, you gotta think of how to do that creatively. it's the engineers who think about that. There is no fixed formula for that.
These automation's craftsmen are ready to do the job for you. Our rotary orienting feeders are built to last. Standard construction consists of a solid metal disc and bowl.
There's also an air tube there. Look at that the tube.
Both lined with
But then the
FDA
design
polymer.
change would be pretty expensive.
Yeah.
Imagine changing the cap a little bit and you just...
Yeah, you gotta adjust things and experiment.
Thing to provide smooth handling. Rotary orienting feeders are used in many different industries such as consumer products, fasteners, health and beauty, automotive, cosmetics, food, pharmaceuticals, packaging, and plastics.
Okay, so again, this plate basically throw out the stacking parts. So only a single flat row of parts coming in.
For more information about Syncron rotary feeders, contact Homer City Automation.
Okay, so that's
In general, vibratory feeders contribute.
okay. We saw that. I think
Meet your specific requirements.
yeah, we saw that one. Okay, now you can also do this linearly. So this one is a linear feeder, not rotary. And you can do like even powders, not just unit parts. Just the intensity. So these vibrates can actually move material down. So again, you don't need somebody to shake it, right? Just have a machine shake it. And you can actually move up a bit, like an incline. Not extreme, but you know. Now here's different trap design and a rejection mechanism.
Vibratory ball feeders are a widely used option for industrial part feeding. However, designing this feeder type is still largely manual and based on trial and error. Generally, the orienting capability of the vibratory ball feeders are designed from a number of standard orientation mechanisms, also called traps. These traps are adapted to a specific part by varying the geometric parameters of the trap. An essential task of vibratory ball feeder.
So these are called traps, okay? So you can have slots, you can have a step, different shapes.
The design is thus determining an optimal parameter setting. To efficiently facilitate this task, we propose the use of dynamic simulation to evaluate trap design opposed to physical construction. This work presents an efficient approach to optimize multi-parameter traps. In each iteration of the optimization, an experiment is conducted with a specific geometry variation of the trap. Here, the potential best geometry variation or parameter set is chosen based on the upper bound of the confidence interval. An experiment covers a simulation of a single part being vibrated across the trap. This results in either that the trap has the desired effect on the part or that it does not. This success or failure is the only feedback to the learning algorithm. The optimization is shown here for a two-parameter trap.
So it's not like you're making a totally blind guess. You can simulate this and you can actually have statistics of, you know, what's the rate of success if I do this. Because see, if 80% is rejected, then your feeding rate becomes very reduced, very much reduced.
The approach is based on Bayesian optimization and uses the upper confidence bound as selection function. The optimization is used to optimize two distinct sequences, where each sequence orients the part to a specific target orientation. The models of the optimized traps are combined to make a full bowl design and tested in simulation. The sequence consisting of a step and a slotted track, is unable to fully orient the part to the target orientation, as some parts in the upright orientation are not toggled by the step.
So that guy's
However, the sequence consisting of the side step track and the wall projection and narrow track ensures that all parts use the
so you want
target
as
orientation.
many yield as possible.
Finally, the two designs are prototyped and tested on a real vibratory feeder. We find that there is good correspondence between the estimation of the simulation and the observed performance of the real setup. In conclusion, the optimization strategy determines good parameter sets for the traps, which are directly applicable for a real.
Okay, I think it's a cool device and it's a cool design challenge. Okay, so this is a linear feeder, right? This is a linear feeder and this is the bolt. So it's a combination. This guy is a QC, making sure, you know, the dimensions or there is no defect. So this is already a combination of multiple things going on. All right, so oops. Alright, that's just another example. Now, one of the most difficult things to handle is actually paper. Think about handling a paper or a cardboard box. So you need suction cup, combination with some arms. Okay, paper is one of the most difficult to handle. Like your printer can have a paper jam, right? Because it takes up two pieces of paper instead of one. So you see, it's a combination of a suction cup and like a rubber conveyor picking it up. So there is an arm and there is a rubber belt picking it up. Okay, so we'll discuss suction cup more next week. But this is how you handle papers. So this thing is moving, right? This belt conveyor, and these are just bearing rollers to keep things in place and keep some pressure on. Okay, so we'll talk more about this next week. All right, that's it. I think we ran out of time, so submit your assignments into Google Classroom like now, because it's an in-class activity, so I don't give you extra time. All right? What?
You have a question? Yes.
No, it's a mistake.
Yeah.
Okay, it's under week 2, the assignment that I just started. Okay.
Yang tadi jam 5 itu ya.
I just sent it to your email, right?
Okay.
It's on my desk. Oh, thank you.
Apaan baterai lu? Gua lihat Nvidia kemarin update downloadnya 112%. Dapat bonus itu lu. Dapat bonus 12% lumayan. Mana ada kuota juga. Gelap.
Alright, see you guys.
Si Nvidia kasih mumpung pakai kuota dia bilang lumayan nih. Itu sih gua pakai wifi. Oh. Tapi lu lihat persenannya kan terus sampai 100. Itu sampai 200 ya. Main kualitas semua di spot. Lu lihat kan downloadnya 200. Enak kok. Nvidia tengil nih. Karena ada 114% malah bapak lu terus 114%. Gratis dia sebenarnya update gitu emang passion di situ kadang ada bug soalnya
Kalkulator asli 15 juta kan. Sekarang udah ada yang jual. Iya makanya ada yang jual kawin itu.
Kok malah begitu?
Iya. Smart card SC2 bisa 20 juta. Tapi dia itu karbunya mirip injeksi, dia bisa otomatis kompensasi, altitude compensation. Baru kayak kalau beda air pressure dia bisa otomatis sekuru sendiri.
mechanical kan.
Iya mechanical. Cuman gila mahal banget.
Iya tuh pakai throttle body yang open nggak sih?
Iya.
Yang dari luar. Wah ada main gitu kan?
Dia bisa ganti sendiri, tapi semuanya full mechanical. Jadi kayak yang EFI tapi full mechanical.
Mendingan EFI sih.
Iya, harga segitu sih buat EFI sih.
Elective Pantas.
Hah?
Enggak ganti elective Pantas.
Mantap. Kok bisa
Kayak kita nggak selama ini bang.
Lu lihat tuh tadi gua ada.
Di bawah kita masih ada Hansen.
Iya, gua.
Enggak, di bawah kita masih ada Hansen. Serendah-rendahnya kita ada Hansen tuh. Mau lu main CS Valorant pun juga tetep aja. Main game mau pun juga lucu. Ayo gitu. Ayo. Ayo. Gue taruhan. Nyawa gue deh. Main apa? Oh, sekarang dulu lihat kayak dia tuh nggak bisa ngarot, cuma dia
Ya udah.
untuk orang goblok ya.
Tadi gua videoin.
Ada versi baru.
Nih.
Wow, so.
Yang
Wow. Gua apa ya? Semua artikel yang gua buka gitu.
Rusak. Bingung gua.
Makanya.
Mana?
Gua anjing. Yang bronze kan yang ownernya yang ini.
Gue tadi pagi bangun lihat HP, bapak gue bilang, oh udah dibeli ya, estimasi datang besok.
Kalau nggak main pasti ada yang bukan.
Itu Nvidia.
Anjing.
25% lagi.
Gue hari Jumat ini, gue mau ke weightlifting gym.
Paling dikit kok.
Udah jago.
Kalau misalkan
Ke gym apa?
Weightlifting gym.
Adreng pas buka kan
Kalau gue bisa sih.
gimana ya?
Ya enggak lah, ada insentif buat ke gym khusus.
Tapi gue dari bronze, gue naikin ke gold.
Kenapa gak nyari gym
Terus
Majapahit?
lu terakhir gue berapa kapan?
Udah nggak?
Masalahnya mereka nggak ada deadlift platform.
Soalnya dari kan
Bumper plates. All I need is a deadlift platform.
Maksud gue stay di culture.
Kalau ada kamu itu tuh 2
Mau balik juling dong.
main sampai tahun depan nggak sampai akhir lagi.
Gue lagi sama software. Oh iya, gue baru ingat. Bro pengen pulang cepet aja, cepet aja.
Ya, paling aku nulis dulu enggak ada.
Ayo, see ya, guys.
Ya sih. Itu buka ini gua senior pasti.
Kononnya terakhir main tuh itu. Dia platinum ya tadi. Platinum beneran. Terus-terusan kalau kayak masih satu.
Jo aja enggak pernah dain.
Bye bye guys.
Gak bisa.
Ganti kelas aja.
Lu dengar ada Mari ngomong apa? Lu nggak dengar?
Hacknya ini lebih bagus buat setting-setting.
Ada yang ngomong lu gak bisa ke diver. Yang harus
Ini?
yang harus aku bilang gitu. Yang harus aku bilang gitu. Dan saya stuck di gold semua. Malahan dia yang bikin kita stuck ya. Stuck ngajak-ngajak. Gua kalau duo sama Marco udah diamond sekarang ini cuma cara kita berbaik hati aja. Iya anjir, bisa aja kita duo.
Gua mah soprek aja.
Dia gua berapa sih?
Kalau gua maju duo dia main enggak pernah serius. Kecuali ada betting. Ngomong gua tuan lagi. Satu semester.
Gila alasan dia sekarang. Itu cuma karena kita berbaik hati aja.
Please. Main santai. BOM gimana sama dia?
Kan gua udah ngomong.
Udah bilang tadi ke dia.
Udah dikirim.
Dia pernah bawa ya, jadi rasanya positif sih kan.
Ya, semua sih 90% gitu ya. Ya udah, jadi yang kurangnya ya beli aja kita sama sistem proses pemain.
Tapi maksudnya kayak dengan kondisi paksel dengan sama yang kayak kemarin tetap kebantu.
Ya banget nggak sih 90% tuh.
Tapi even buat nanti kalau makin banyak orang daftar. Karena kita kan masih belum closing. Ninggalin kita kok.
Kalau mau gimana kalau misalnya nanti ada makin banyak orang daftar, kita tambahin aja komponen-komponen yang belum. Dan setidaknya ada yang di
Udah ada. Setidaknya udah ada satu step.
Ya.
Berarti lu nggak download
Jadi kalau ada orang datang lagi, tetap aja kan mintanya tambahin infonya banyak. Buat nutup yang
Absolut cinema. Artinya beda arah.
Beda arah. Lu sama arah.
Goblok banget.
Over lagi. Duplikasi.
Emang lagi kayak hutan cowok. Emang defect. Woi dari lahir kita justru kita.
Wow.
Yang ada begitu
100
Gini nih. Cok. Bohong ya lu pernah itu aja kan lu. Cok 15% 8 menit lagi gol.
Keren.
16 cok 16 sudah cepat. AMD software. Emang lu enggak ada? Ada, tapi tadi apa mereka hapus kan mau custom installation. Oh. Lo pencet custom installation? Iya. Besok aja kasih Jo. Cok, kalau ini enggak, kalau gua enggak bisa main. Custom installation kalau harus main. Hah? Custom installation besok tuh.
Jo, lu bilang gua hard start gold kan?
Jo.
Gua serius besok udah plat.
Benar ya? Ya. Benar ya? Kalau enggak, ayo makan lo seminggu. Enggak, ini taruh download satu deh. Kalau lu besok enggak plat, traktir gua ngajak makan. Nah, gitu lah.
Sehari doang.
Ya, boleh ya. Hari ini, dari besok kan berarti hari ini lu ke plat langsung kan?
Satu kali makan.
Oke. Ya, sekali.
Kalau gua plat
Apa ya?
tuan.
Ya udah tuan.
Semester, satu semester.
Apa? Satu semester? Enggak. Kalau lu yang bisa ke plat, gua maju beli lu makan berarti 2 kali maksudnya. Jadi lu dapat makan 2 kali.
Oh, makan dan minum.
Ya udah.
Oh, enggak.
Nanti by tomorrow ya. Deadline-nya berarti jam 12 malam ini. Ayo tuh, nyampe platnya. Berarti kalau nyampe platnya jam 1 pagi kan udah masuk besok.
Jadi dia masih main like literally now sama.
Iya.
Goblok.
Enggak ada. Loh, kan
Gak ada apa?
bilang deal enggak?
Kan deadline-nya ini jam 12 malam hari ini.
Deal enggak? Langsung pulang.
Mau main sama gua?
Ya udah ayo, jom kita berarti trio aja kasih dia sendiri aja. Masih lainnya apa? Hah? Dia gol 2, 3. Tapi 0 poin, tapi 0. Hah? Mau jatuh. Dia bilang, ayo kita bantu nanti. Boleh. Yuk kita, hashtag kita pro game-nya.
Gak ada dia mungkin mau.
Tapi gua nggak tahu sih gua malam ini bisa nggak. Iya lu berangkat dulu siapa?
Itu bukan meeting. MPM meeting gak sih ini? Gue denger BEM meeting.